Good afternoon. How are you doing? Had a great lunch? Great. Well, my name is Mike Bowman, and I'm going to talk about how to use Hadoop for solving the big data of security problem we have. The thing is that you hear about a lot of big data, what you can do with big data, and the thing is, what we're having now, today, is big data in security. We have log files in terabytes, network traffic. I mean, and the standard desktop is 1 terabyte disk space, even if you're doing computer forensics. And not talk about malware, that's an insane amount of data. And that's where I'm coming from. I'm not coming from big data, I'm doing Hadoop, and let's see what I can do with security. I'm a malware analyst as a hobbyist. I was here in 2012 and talked about my 3 computers under the stairs in my house doing malware as a hobby. And it's been progressing from that, where I'm also spoke about how to do it cheaply and how to make use of the data. The thing is, from 2012 to now, my malware collection has grown really big. And my 3 computers under the stairs is not really cutting it. Because I'm going to go like, collect all the malware! And it's a lot. This is just one of my sources of malware. It's from beginning of 2012 to about now. Anyone can guess how much malware that is from that single source? How many things? 1 terabyte? Show of hands. I think I can see you. Come on, wake up. No one thinks I have 1 terabyte of malware. You think it's too much? Yeah. What? 50. It's not quite that much. I don't have a SAN at home. See, I'm still under the stairs. Although I want a SAN, I can't afford it, I can't house it. .8 terabytes of disk space from this single source. I have 20 other sources. Now, if you look at the releases, you have one here, 18th of July, 45, almost 46 gigabytes. 3 days later, another one, 25 gigabytes. You can't download them fast enough, let alone analyzing them. There's over 100,000 samples each of these packs. I mean, how can I keep up? Oh, I can't. I need reinforcement. I need help. In more ways than one. So I'm looking at this is a big data problem. What can I do with big data? Oh, looking. Hadoop, that's the open source solution for all big data problems. And it's really, really cool project. It's meant to run off-the-shelf hardware. Now, your normal standard PC that has its faults, the hardware dies, it burns up. And it doesn't require any special networks. I have a friend, he's working in the HPC sector. He's talking about his 1920 CPU's cluster he just installed. It's like 1,920 cores and terabytes of RAM and infinity band network and all the things. And it's like, okay, how much does it cost? 5.6 million. Okay, I come back about 20 years when I've saved all my income, and I can start looking at getting something like that refurbished. So Hadoop, all standard stuff, all standard hardware. The processing is done locally, and that's an important bit. Because this is like the Hadoop ecosystem. The things in the middle, in the circle, are the really important stuff. You have the HDFS, the Hadoop Distributed File System. If you think about RAID, RAID file, you put a file on the hard drives and it's spread over several hard drives and so on. Well, that is what Hadoop does, but across machines. So a standard is that it makes 3 copies. So that piece of data is stored on 3 machines. Then you have the map reduced. It's the computing power. It's actually quite stupid. Think in the easiest way, think grep, pipe it to word count. That's map reduce. The map part is the grep. The reduce part is the word count, the WC command. Of course, you can do a lot of things with either part of them, but that's it in a nutshell. Then you have all these components around them. For me, I'm using pig most of the time, HBase sometimes, but mostly I'm not actually thinking about it. I'm using pig, I'm using HBase, everything else is magic happening. This is a security talk, it's not a big data talk. How do you get a Hadoop cluster? Well, my recommendation, if you're running this at home, get one of those pre-packaged distributions. Cloudera has one, Hortonworks has one, there's several others. You can also rent them using the EMR from Amazon. That's really cool, really cost-effective way to do it. Or if you really, really want, you can compile it yourself. Not recommended unless you want to actually improve the Hadoop ecosystem itself. Because if you just want to use it, go for a pre-package or rent it. So let's talk about how to do malware analysis with Hadoop. Well, first, I'm using a piece of software not developed by me. It's Binary Pig. It solves a lot of these problems. First of all, malware samples are in the size of megabytes. Hadoop likes them larger. So what it does is it's creating a sequence file. It's a key value pair, where the key is the identifier, like the MD5 checksum, and the value is the contents of the malware. Because then you have a lot of malware as one single file. Then these files are batch processed on each and every node in the Hadoop cluster. They are processed locally, which means that the node that does the processing has the data on its own hard drive. So I don't have an additional network I/O to consider. And the output is stored in Elasticsearch for accessing, for more analysis, for drilling down into results. So what do I do with it? I'm doing extracting resource information, which means everything that the PS header is telling me, I'm also collecting all the resources, all the icons of the binary. Something that's interesting to know that malware developers are as lazy as normal developers. Once they find a good icon set, they will keep it, will keep using it. Same thing as if once they have got OpenSSL or some other third-party library working on their machine, they will keep using that version with those specific changes they made to it. And those things are things we can look for in a sample. And you're also looking at how to improve detection rate. So I'm using Yara for that. And every time you're doing a signature update, you want to see how well it responds. You get any false negatives and the false positives. You actually find what you're looking for. So that's really good to run it and rerun the sample or sample set. So this is like the workflow of binary pig. You have a zip file or a local directory with a lot of malware samples. Malware sample is a malicious file. Those who don't know. That file is being sequenced and stored in the Hadoop in the cluster, in the HDFS. Once that part is done, I run a bunch of pig jobs for creating hashes, to do claim A/B scanning, to do the Jara signature detection, to extract all the strings, the resources, whatever I want. And if I figure out that tomorrow, that piece of information I would like to have, write a new pig script that extracts that information for me and rerun the job. With affinity amount of nodes, it can be done really, really quickly. But I'm getting back to that later. Next thing you can do with Hadoop is doing network analysis. That one is similar to the malware analysis, as in you store the PCAPs in HDFS, and you run a bunch of pig scripts to extract the things you're looking for. So if it's, you want to run snort signatures against the whole lot, you can do that. You can do things like, okay, give me all the traffic that didn't have a sort signature. You can replay the traffic, you can look at artifacts, back and forth. The workflow looks like this. PCAP stored locally, uploaded to HDFS across the nodes. And that circle motion is representing all the pig jobs that runs on each individual node. And as I said, it's a POF signature extraction. Have anyone heard about the POF tool? It's actually looking at all the characteristics of a connection to see that, oh, the TTL was default this one. It means that it's probably a Windows machine or a Linux machine or so on. Who is generating the traffic? You get the extract the user agents, whatever you want. I mean, think about the query you're looking for. You can have it. Then you have the computer forensics. And that one is more complicated. It's like you're having tons of storage, you have files, and a normal computer, it takes time to do a keyword search. Well, this is a multi-part process. First, you extract you take the raw image, extract metadata about the raw image, all the files, both about the image itself and the files in the image. You upload that and the raw image to HDFS. Then you're processing that data you got into HBase, it's a NoSQL database. And you do an iteration. You find first all the files, and you find the contents of the files, you categorizing the files, you keyword index the files, and so on. Which means it doesn't do anything different from the normal Slothkit software. It's just doing it faster as you have more processing power to use with it. And the nice thing is that you just need to have enough storage around the whole cluster, not on each machine. So you're extracting keywords, you tokenize the documents, you cluster the similar objects, and you can even compare it to another image. So if you have a plain Windows image, you can remove all those files from the investigation. And then you have the extraction point where you're actually building a report of all the data you got out. So that's really cool. Then we got back to the log analysis. This is the basic example. If you look at how to write a MapReduce job, they always have the example of doing a log analysis, usually Apache logs. Doing a pure MapReduce job for this is okay. It's a bit more work than writing a pig script for it, which is an overlay over MapReduce jobs. It's like writing C instead of assembler. So the workflow when you're doing large scale log analysis is that you're using Flume, which is another of those data acquisition components. They push the local logs to HDFS and normalize them. Then you have pig scripts that all this is batch processing. So you have a batch that using pig scripts to either directly look for bad stuff or populate the HBase database. Because once you have the data in HBase, you can start querying that one for more information. It's like you pipe it to a file, and then you start looking at that file for more information. And this logpig has a RESTful service for data extraction from the Hadoop, so you can actually start using the data in your normal UIs or CIs. So here's comes the animation again. It's quite standard. So Flume push the logs to HDFS. HDFS is spreading it across the computers. You have a pig scripts that extracts the data and puts them back either back to HDFS or in HBase. And then you can create additional pig scripts to extract more information. So back to my little hobby, malware analysis. As I said, I have my 3 computers under the stairs, like Harry Potter, and I'm storing my samples locally. What I need to do is, my 3 nodes at home, they don't cut it. It's not enough computing power. I can't keep up. So what I'm doing is I'm loading the data I'm interested to analyze up to S3, the Amazon Web Service, simple storage service. Then I'm using Elastic MapReduce, Amazon, to run binary pig and extract all the data. And then I pull the results back locally. The reason for I do this is, although S3 is cheap to store data, when you're talking about terabytes of storage, it's no longer cheap. You mean you're talking about hundreds of dollars per month. So this is, as I said, my hobby. So I need to be cost effective and time effective and everything. So data is being backed up on Amazon Glacier. Anyone heard about that one? A few hands. It's their long-time storage solution. You upload it, it's stored on very cheap storage. So if you want it back, you can't be in a hurry. It will take time, but you don't lose it at least. Also doing using the less reduced redundancy storage of S3. So I only have .99 and not .99s. Because I figure it's going to be up there. I have a local copy. It's going to be up there for an hour or 2. It shaves off the cost. The third thing I do is I bid on Amazon EC2 spots, which means that Amazon is having this market where you can buy unused computing power, and it's a market, highest price wins, and you can get the computing power very cheaply. Although if someone bids higher than you, they just turn off your machine. But that's not the problem, because Hadoop is built to actually be aware of that. And it's actually better if they do turn it off before the full hour, because if they terminate your machine before the full hour of machine time is used, they bill you nothing. And Hadoop is doing incremental saves. So if I bid low enough, I get it done fast enough, very, very cheaply. But if time is more important than money, either you can buy your on-demand instances, which means you pay retail price, or just bid a very high price. And the thing with the bid price is the maximum you're willing to pay, not what you are paying. So if you can, if you bid like 5 cents an hour, and the spot price is 1.1 cents an hour, you're just paying 1.1 cents. And this is getting down to about, I estimate about $20 a month. I haven't got my first bill yet, because this is a work in progress. During the summer, the storage node on my home computer, it crashed. I lost half my hard drives and all my malware, so I'm in the process of rebuilding my my archive. So this is how I'm doing it going forward. So conclusions. Malware analysis, it's really appropriate for this kind of setup. You can do it very quickly, very cheaply. And if you figure out a new way to extract data or find a new piece of data you want, you can rerun your whole sample collection in hours. Or if your credit limit is big enough, you can run it in 1 hour and a lot of machines at Amazon. I mean, you could run the whole archive, the 5.8 terabyte of malware in just under an hour. But you're paying for it. But it's cheap. You can do it for network analysis. And if you're recording all the traffic, dump it to HDFS, you can start rerunning samples. You can develop your own signatures. It's like you have you find an exploit or malicious network pattern, and you write your snort signature. You can run that snort signature again at all the traffic already collected and see if you got any false positives, or if there are any other machines that has been attacked. Same thing with the computer forensics. And here I think Hadoop is a really good tool because you don't need 10 terabytes of disk space in each and every node. I mean, you can have 500 gigabytes disk space, provided you have enough nodes. Because the capacity of HDFS is the disk space across all your nodes divided by 3. As you're storing the same data 3 times over the cluster. And for log analysis, this is the newest part of my ecosystem, and I'm already seeing benefits of it, especially when you're taking in logs from the dynamic analysis of malware binaries, all the system calls. Next step is to actually create computer learning algorithms to help me detect bad stuff.